Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in P1, trigonometry is a very extensive and important chapter. Let's get started with the first lecture. Now just a brief overview of what we have done in O-level trigonometry. That is, if we look at a right angle triangle, we have three main ratios. That is sine, cos, and tangent. And when we talk about these three ratios, that is sine, cos, and tangent, they are related to three sides of a triangle. Sine is related to opposite and hypotenuse. So from the perspective of the angle, this is the opposite. From the perspective of the angle, this is the adjacent. From the perspective of the 90-degree angle, this is the hypotenuse. So sine is opposite over hypotenuse. H for hypotenuse, I'm using this symbol. And then we have this thing, which is cosine. That is adjacent over hypotenuse and tangent opposite over adjacent. So based upon this, let me use a triangle over here. And I'm interested in exact trigonometric ratios for some special angles. So let me label this angle as 30 degrees. And sine of 30 degrees, that is 1 over 2, a very commonly used value. That means 1 corresponds to the opposite side, that is 1, and 2 corresponds to the hypotenuse, that is this. Therefore, I'm interested in finding the base. So therefore, hypotenuse square is equals to opposite square plus adjacent square. So this is 2 square, this is 1 square, this is b square. Therefore, b comes out to be, b square is 3, therefore b is square root of 3. We only take the positive value. Based upon this, I'll write cos of theta, that is root 3 over 2, because this is adjacent over the hypotenuse. And similarly, tangent of theta, actually it's not theta, it's 30 degrees because we use it so much. That is why it becomes easy on our tongue. So this is cos of 30 is this much. Tangent of 30 is 1 over root 3. I'm not focusing on rationalization for right now. So now if I have these three values, and let me just take this thing and put it somewhere over here. That is for later use. So therefore, I have this thing. And let me just copy this much. And people always remember one thing. When we are starting with something, of course, the pace will be slow and sooner or gradually it will increase. So there is no hurry as such. This is this much. This is tangent. This is this much. Now, if this is 30 degree, let me label this particular angle at the top. This is 60 degrees because this is 90. These two should add up to 90 also. Now, from the perspective of 60, now this is the opposite for 60. This is the adjacent for 60. The tables have turned. The 90-degree angle is still the same. So therefore, the hypotenuse is still the same. So now sine of 60, that is base, which is root 3 over 2. And cosine of 60 is adjacent, which is 1 over 2. And tangent of 60 is root 3 over 1, because the base and the opposite have changed. Now, let me grab this thing, take it on the next page. And let me first focus on this particular diagram. Now, what do you observe? We observe the following. That is sine of 30 and cos of 60 is the same. We observe cos of 30 and sine of 60 is the same. We observe that tangent of 30 and tangent of 60, they are reciprocals of one another. Now keep this observation to yourself for right now. Let me move to another triangle. So now this is a right angle isosceles triangle. right angled isosceles triangle such that both angles are 45 degrees, because if one of them is 90, the other two should add up to 90. They are equal, they are 45 degrees each. Tangent of 45 is 1. 1 can be written as 1 over 1. So let me write 1 in the simplest ratio. Let me write 1 in the simplest ratio. This is the hypotenuse. So therefore, hypotenuse square is 1 square plus 1 square, which is 2. Therefore, hypotenuse is square root of 2. So hypotenuse is square root of 2. Therefore, sine of 60, sine of 45, not 60. Sine of 45 is 1 over root 2. Cos of 45 is also 1 over root 2. Now, these are the ratios that I have for right now. Now, let me draw one other triangle. And let me just draw it over here. So the third triangle that I'm drawing, that is for just a general thing like this. Okay. So now if I label this angle as theta, and this is a right angle triangle, this is A, this is B, this is C, symbolically I'm talking about. Sine of theta is A over C. Cosine of theta is B over C. Tangent of theta is A over B. All good? Now, if this is theta, let me label this thing as phi. So this is theta. Some people call it theta also, no issue. This is beta. And this is phi, phi, phi. So now, if I talk about sine of phi, that would be B over C. Cosine of phi, not theta, cosine of phi, that is A over C. Tangent of phi, that is B over A. Again, focus on this thing. Sine of theta and cosine of phi is the same thing. Similarly, cosine of theta and sine of phi is the same thing. Similarly, tangent of theta and tangent of phi, they are reciprocals of one another. Now, what is the relationship between them? The relationship is simple. Over here, 30 and 60 adds up to 90. Over here, 45 adds up to 90. And over here, beta and theta and phi adds up to 90. So now here is the result that you should be aware of. That result is this thing. The result says if two angles add up to 90 degrees, complementary angles, two angles add up to 90 degrees. I'll just pause for azan. So now, if two angles are adding up to 90 degrees, we call them complementary angle. The sine of one of them, sine of 90 minus theta, should be the same thing as cosine of theta. Cosine of 90 minus theta should be sine theta. Tangent of 90 minus theta should be 1 over tangent of theta. That is what you see over here very, very clearly. Sine of 30, cos of 60. 30 and 60 adds up to be the same. That means if this is theta, this is 90 minus theta. Cos of 30, sine of 60 is the same, but tan of 30, tan of 60, they are reciprocals of one another. So now this thing is done and dusted. Let's also talk about rationalization. Those people who have given O levels this year, and of course, all of you belong to that category, surds was added to the syllabus this year. 1 over root 2. How do we get rid of the square root from the denominator? Multiply and divide by root 2. So therefore, the answer is root 2 at the top and 2 at the bottom. So these two have the same value. One is unrationalized, the other one is rationalized. Rationalization means getting rid of square root from denominator. So that is the logic that we apply. Similarly, 1 over root 3, multiply and divide by root 3. So what do we have? We have root 3 at the top, and root 3 becomes 3. What is the logic? A power half, a power half, that is a power half plus half, which is a power 1. A power half is root A, that comes out to be A. That is the logic over here. Now let's move on and let's continue with the second thing. That second thing is about supplementary angles. So we need to have a very, very strong grip on the basics. Supplementary angles. That means angles that add up to 180 degrees. Now, this thing will be taught in a different manner. So now let me write down some angles. Let me write down 30 degrees and 150 degrees. Sine of 30 is half. If you use a calculator, sine of 150 is also half. Let me choose another pair, 60 degrees, 120 degrees. Sine of 60 degrees, that is root 3 over 2. Sine of 120 degrees is also root 3 over 2. Now look at these angles. 30 and 150 adds up to 30 and 150 adds up to 180. 60 and 120 adds up to 180. In other words, I can say if one of them is theta, the other one is 180 minus theta. So sine of theta and sine of 180 minus theta is the same. So therefore, we have this particular ratio, which is sine of 180 minus theta is sine theta. All good, all clear? Now, let me move ahead with the same idea. It's the same idea that I'm pursuing. Let me choose 30. Let me choose 150. Let me choose 20 degrees. Let me choose 160 degrees. Let me talk about cosine. So now I want you people to also grab your calculator and make sure it's in the degree mode. Cos of 30. That is 0.8660. I'm also working in decimals. Cos of 150 degrees, that is negative 0.8660. Now let me write 20 cosine, that is 9397. Cos of 20 is 0.9397. Cos of 160 is negative 0.9397. What do we observe? We observe this thing, that is 30 and 150 adds up to 180. One of the cosine is positive, the other one is negative. 20 and 160 adds up to 180. The cosine has a negative positive value, the other cosine has a negative value. That means this one is acute, this one is obtuse. Cosine of acute is positive, cosine of obtuse is negative. Cosine of acute is positive, cosine of obtuse is negative. If the two angles are adding up to 180 degrees, now I have this rule. Cosine of 180 minus theta is the same thing as cosine of theta, but with a negative sign. So if I want to equate that these two are the same, so therefore I can say cosine of 160 is negative. This thing is positive, so apply a negative sign over here. That negative sign is right over here. Is this all good, all clear? So let me write on the group because you have to be active on the group also. So cosine, supplementary thing. Is this all good, all clear? That is the second thing. Acha ji. So now let's move on. Again, the same thing. Let's talk about tangent. Uh, 30 degrees, 150 degrees. Let me write 60 degrees, 120 degrees. Let me write 45 degrees, 135 degrees. And tangent of 30, let me write it in decimals. I think 0.577. 30 tangent, yes. Tangent of 30 is 0.577. Tangent of 150 is negative 0.577. Tangent of 60, that is square root of 3. Tangent of 120, negative square root 3. Tangent of 45, that is 1. Tangent of 135, that is negative 1. What do we observe? We observe the following. That is 30, 150 adds up to 180. Tangent of acute is positive. Tangent of obtuse is negative. Acute positive, obtuse negative. Acute positive, obtuse negative. So again, tangent of acute is positive. Tangent of obtuse is negative. And if they're adding up to 180 degrees, they have the same ratio. So tangent of 180 minus theta is also negative tan theta. So now that is another rule that we need. So now double check. Only sine is such that sine of acute and sine of obtuse, it's the same. Sine of acute, sine of obtuse, that is a ugly obtuse, hold for a second, is are the same. They both are positive. Now, what is the bottom line of the story? So the bottom line of the story is this thing. If two angles are adding up to 180 degrees, supplementary angles. If two angles are adding up to 180 degrees for sine, sine of 180 minus theta is sine theta. And let me just write without the bracket. Cosine of 180 degrees minus theta, that is negative cosine theta. Negative cosine of theta. And then a negative, and let me write over here, tangent of theta. This is tangent of 180 degrees minus theta. So far, so good. Now, let me introduce the concept that about quadrants. So now let me draw a few diagrams, and I think there should be a grid over here. Yes, I think that's the one. Okay. So okay. So let me first realign them. Okay, and let me just recapture them. Change the color. Add element, sketch. Okay. Now, first of all, before we get started to this, let me write down few ground rules. The rule is anti-clockwise angles are considered positive. Therefore, clockwise angles in trigonometry, they are considered negative. Angles are measured with respect to x-axis, and that is the positive x-axis. These are the three ground rules that you should worry about. So now over here, let me draw some angles. And there is one angle like this. It's not drawn to scale, just a diagram. The other one is like this. The third one goes in this direction. Fourth one goes in this direction. And let me draw some more diagrams. Some more. Okay, so now make sure your calculators are ready. And we can also use the trig ratios. Now over here, first of all, let me label this angle as 30 degrees. This is with respect to x-axis. This angle is 150 degrees, again with respect to x-axis. This one is 210 degrees with respect to x-axis. This one is 330 degrees with respect to x-axis. And we are going clockwise in all of these. So let me write anti-clockwise angle is 30, anti-clockwise angle is 150, anti-clockwise angle is 210, anti-clockwise angle is 330 degrees. Now, if I calculate the sine and all this thing related to this, what do we see in this one? Let me add a page and let me write over here 4 angles. That is 30, 150, 210, 330 degrees. And let me just shorten it. And let me write the ratio from here. That is sine. Sine of 30 is 1 over 2. Sine of 150 is 1 over 2. Sine of 210 is negative half. Sine of 330 is negative half. This angle is an acute angle. This angle is obtuse angle. This angle is reflex. This is also reflex. So in order to differentiate between the two, this is reflex 1, this is reflex 2. So now what do we observe? We observe that sine is negative in these, for these two values, sine is positive for these two values. Now, this one is called first quadrant. This is quadrant 1. This is quadrant 2, quadrant 3, quadrant 4. So now, when we are talking about this thing, this is the first quadrant. This region is second quadrant. This region is third quadrant. They are labeled anti-clockwise because that is how we go. We go from first to second to third to fourth. That's how the quadrants are labeled. All good? So let me just shift this thing down so I can label the quadrants properly in this diagram also. Okay, let me just put it over here. All good. So now let me label this thing. So now this is y-axis, x-axis. This is first quadrant, second quadrant, third quadrant, fourth quadrant. First is related with acute angle. Second is related with obtuse angle. Third is related with reflex 1. And fourth is related with reflex 2. All good? So now when we are looking at sine, what do we observe? That sine is positive for the first two quadrants. So we say sine, let me mark it in red. Sine is positive over here, sine is positive over here, sine is negative over here, sine is negative over here. Red color denotes sine. That is the first thing. Let me talk about cosine. So cosine of 30, that is positive root 3 over 2, root 3 over 2, root 3 over 2, root 3 over 2. The first one is positive, fourth one is positive, second one is negative, third one is negative. That is what we observe over here. And let me just change the colors also over here. Negative, negative. So now when we talk about cosine, what do we observe? It's positive in the first, positive in the fourth, positive in the first, positive in the fourth. So blue stands for cosine. And let me just remove the negative signs. So negative over here is removed, negative is removed. So cosine is positive in first and fourth, sine is positive in first and second. Let me talk about tangent. Tangent of 30 degrees is 1 over root 3. It's the same ratio, and there is a particular reason for that. Cosine a tangent, it's positive in first and third, negative in second and fourth. Positive in first and third, negative in second and fourth. I'm just labeling the positive ones. So when we talk about the first quadrant, all ratios are positive. Red stands for, before that, let me write tangent in green. So red stands for sine. So I'll write only sine is positive. Green stands for tangent. Only tan is positive. Blue stands for cosine. So let me just pull this up. Not this thing, this thing. So first of all, let me just push it like this. Okay. So now over here, the blue thing, only cosine is positive. Got the idea? That is based upon all this thing. So now is this the table very clear? So now over here, let me write over here table sine, cosine, tangent, quadrants. Is this all good? All clear? Quadrants, not quadrants. Quadrants, is this all good? All clear? Now there is another hidden story in this one, and that I'll come to it in a short while. So first of all, I'm talking about all these things. And let me just shift the page like this. So we were talking about anti-clockwise angles are positive, clockwise angles are negative, angles are measured with respect to positive x-axis. That is how the quadrants are labeled. Let me label them once again. So the quadrants are labeled like this. This is the, hold for a second. So this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant with respect to x-axis, and we are going in an anti-clockwise direction. That is why anti-clockwise angles are positive. That is why they are labeled this way. So now just focus on this. Sine is positive in first and second quadrant. Cosine is positive in first and fourth quadrant. Tangent is positive in first and third quadrant. If it's not positive, naturally it's negative. And that is the ratio that we have over here. Let me again copy this whole thing and let me write it over here, paste it over here. And let me just remove this thing, that is the stroke eraser. Okay, so now only all the ratios are positive. So we have this thing, all ratios are positive. Only sine is positive. Only tangent is positive. Only cosine is positive. Now, there is another hidden story. That is there anything special about these angles that they are giving us the same ratio irrespective of the sign? Yes, there is something special about it. That means if I look at all of these, what I observe is that the angle with the x-axis is also 30. So over here, this is 30. This thing is also 30. Over here, this is 150. 180 minus 150 is 30. Over here, this is 210. 210 minus 180, that is also 30. Over here, 360 minus 30, that is also 30. That means the basic angle, the angle, actually acute angle with x-axis is the same. That is the definition of basic angle. So in all four of these angles, 30, 150, 210, 330, they have the same basic angle. So first quadrant, 30 degrees is the angle. Second quadrant, 150 degrees has a basic angle of 30. In the third quadrant, 210 degrees also has a basic angle of 30. In the fourth quadrant, 330 degrees also has a basic angle of 30. That means let me add a page in the middle and let me just deal with the basic angles first. So now, if theta is the required angle in the question, and this thing alpha is the basic angle, the acute angle with x-axis, what is the relationship? The relationship is this: first, second, third, fourth. In the first quadrant, theta is the same thing as alpha. This is alpha, this is theta. Theta plus alpha adds up to 180 degrees. Therefore, theta is 180 degrees minus alpha. This is theta. Actually, this is alpha. This whole thing is theta. So theta is 180 plus alpha. This up till here, it's 180. And this is alpha, this is theta. Theta plus alpha is 360 degrees. Therefore, theta is 360 degrees minus alpha. First quadrant, theta is alpha. Second quadrant, theta is 180 minus alpha. Third quadrant, theta is 180 plus alpha. Fourth quadrant, theta is 360 minus alpha. Again, I need one single diagram to sum it all up. What is the summary? The summary is this. No, that's not the summary. That is the x-axis. That is the y-axis. In the first quadrant, theta is alpha. In the second quadrant, theta is 180 minus alpha. In the third quadrant, theta is 180 plus alpha. In the fourth quadrant, theta is 360 minus alpha. There is no mention of 270 degrees. And don't forget, all the three trig ratios are positive. Only sine is positive. Only tangent is positive. Only cosine is positive. That is the summary of all what we have done over here till now. So now, till now, the diagram says it all. So now we talked about exact trig ratio. We talk about this diagram. I hope this is all good, all clear. Now, let me introduce some other angles. So first of all, we talked about this thing. That's right over here, 30, 150, 210, 330. And we talked about sine, cos, tan, and everything. And of course, it is related to, there is so much for you to copy. So that is related to this thing, which is sine of 30, cos of 30, tan of 30, sine of 60, cos of 60, tan of 60, sine of 45, cos of 45, tan of 45. So it's everything is related to this. So now these are the major decision makers. So over here, we were talking about 30 degrees and its relatives. So first of all, this is 30 degrees and its relatives. When we talk about 30 degrees and its relatives, in all four quadrants. So which four angles are we talking about? We are talking about 30, 150, 210, and 330. And that was the analysis that we got. Now let me talk about other angles. That is 60 degrees and its relatives in all four chords. Okay, so now this is 60, this is 120, this is 240, this one is 300 degrees. Focus on the angles. This basic angle is 60. Over here, this is 60, 120 plus 60, 180. 240 minus 60, that is 180. It looks weird writing over here. That is 60. And this thing is 60. The basic angle is the same. That means if I draw another thing over here, just like I did for 60 degrees. So let me write over here. That is 60 and 180 minus 60, 120. 180 plus 60, 240. 360 minus 60, 300. If I talk about sine of 60, that is root 3 over 2. Let me first write down all the ratios. They have the same basic angle. That is why the ratios are the same. Cosine of 60, this is half, 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 and half. Tangent of 60, that is root 3 over 1, root 3 over 1, root 3 over 1, root 3 over 1. Now, first of all, when we talk about sine, the first two are positive, the next two are negative. When we talk about cosine, the first and the fourth are positive, the middle two are negative. When we talk about tangent, first and third are positive, second and fourth are negative. Again, they have the same ratio. So let me write a statement over here, and that applies to all. That is if basic angle is the same, then trig ratios are the same, irrespective of positive, negative sign. So now 60, 120, 240, 300, this is all good, all clear. Let me look at this angle. 45, 180 minus 45, 135. Let me write it properly. This is 180 plus 45, that is 225. This is 360 minus 45, that is 315. Again, focus on the basic angle. In the first quadrant, basic angle and theta is the same. Over here, this is 45. 135 plus 45, 180. 225 minus 45, 180. 360 minus 45, 180. So 45 degree is the basic angle over here. And let me go up. 60 degrees is the basic angle in these four diagrams. Let me go further up. That is the 30 degrees is the basic angle over here. All good, all clear? So now let me write down the ratios over here. For this one, let me write down the four things. That is 45, first quadrant, 135, second quadrant, 225, third quadrant, and 315, fourth quadrant. So this is first, this is second, this is third, this is fourth, this is acute. Focusing on this. This is obtuse. This is reflex 1, REF1. This is reflex 2. Let's talk about sine. Let's talk about cosine. Let's talk about tangent. So for sine, this is 1 over root 2. 1 over root 2. Always focus on the value, apply the sign later. Remember my golden words. Always focus on the value, apply the sign later. Tangent of 45 is 1. Red color for sine, positive for first two quadrants, negative for these two. Blue is for cosine, positive for first and fourth, negative for the middle two. Green for tangent, positive for first and third quadrant, negative for the middle two. Over here, which is the basic angle, 45 degree is the basic angle, the acute angle with the x-axis. So now the story of 30, 60, 45. Is this all good, all clear? Sorry. Okay, so I'm just waiting for the acknowledgement. Okay. So that is the very, very summary of this thing. I'm not talking about acute. No, I'm not talking about clockwise at this point. That will come up a bit later. Now, let me talk about this thing. Let me just shift this thing. Hold for a second. So now let me talk about some worked examples. So now some exam-based questions. So something like this. So now some exam type questions related to all this thing, whatever we have studied. Worked example 1. Uh, Sine theta is given as 3/5 and theta is acute. Evaluate the following. Part A, cosine theta. Part B, tangent theta. I'll just stick to these basic things initially. Let me draw a triangle. So this is a right angle triangle that you have to draw. Nothing, no scale diagram, nothing like that. And I also would like this to be part of this for a second. So let me just choose this thing. Add element. So now, first of all, this thing is there. Let me just do one other thing. That is, I'll be changing the question and the diagram with few adjustments. So let me go to the next page. And the page after that. Okay. So we'll be doing 3 questions or maybe more, and based upon this. Evaluate cosine, evaluate tangent, sine and theta is positive, theta is acute. So first thing first, based upon this, you will write acute. That means sine will be positive, cos will be positive, tan will be positive because we are talking about quadrant 1. That is the first thing that you should have in mind. Second thing you should have in mind is this, that the opposite side is 3. So this is 3. And the hypotenuse is 5. The hypotenuse is 5. And of course, it's a right angle triangle that you have to work with. So based upon this, the base is coming out to be 4 because it's a Pythagoras theorem thing. That brings me to another thing, which is, let me draw a triangle thing over here. So now let me write the famous right angled triangles. So there is 3, 4, 5. There is 6, 8, 10. There is 5, 12, 13. There is 7, 24, 25. So these are some of the famous right angle triangles. So if 3 and 5 are given, the base is 4. This is theta over here. And cosine of theta is 4 over 5. Tangent of theta is 3 over 4. Since it's acute angle, therefore this is positive, this is positive. That's how it's done. As simple as this. Of course, I can ask further questions. For right now, let's just focus on this. Worked example 2. So now worked example 2. Sine theta is still 3 over 5. Let me change these two things. Therefore, theta lies between 90 and 180. Now we are talking about obtuse angle. Therefore, only sine is positive because we are in quadrant 2. Got the idea? Now we won't change the triangle. The triangle is always drawn for positive ratios. So this is theta, this is 3, this is 5, this is 4 by Pythagoras theorem. Cos theta, it's 4 over 5. Tangent theta is 3 over 4. And since cosine is negative, therefore give it a negative sign. Tangent is negative, give it a negative sign, because in the second quadrant, only sine is positive. Is this all good, all clear? So basically, assign positive, negative at the very end. That's the first thing. Second thing, the lengths of triangles are always written as positive. Therefore, we assign the sign at the very end. Is this all good, all clear? So now worked example 2 is also done. Let me go to worked example 3. Now, worked example 3, I'm just deliberately using the same ratios. And this time, let me write sine theta is negative 3 over 5. Theta lies between 180 and 270 degrees. That means we are talking about reflex one angle. We are talking about third quadrant. And in the third quadrant, only tangent is positive. We know that. And we can see that there is a negative sign with the sign. So now over here, this is theta, this is 90, this is 3, this is 5, this is 4. Based upon calculation, the negative sign does not appear. Cosine of theta is 4 over 5. Tangent of theta is 3 over 4. Tangent is positive, give it a positive sign. Cosine is negative, give it a negative sign. And this is worked example 3. So worked example WEX3 is this all good, all clear. It's rightly visible in front of your screen. Okay, so even if sign is negative, something else is negative, it doesn't change the ground reality. All good? So now let me just do one more example. I hope the pasting is there. Yeah. Now this time, let me choose another ratio. And I'll be doing one more in which it would be symbolic or maybe something else. Now worked example 4. And this time, I'm using different ratios. Let me change this. Worked example 4, and I can even work with cosine. So therefore, cosine of theta is equals to 2 over root 7. And theta is in the fourth quadrant between 270 degrees and 360 degrees. I want to evaluate cosine and tangent. One other thing that you have observed, that whatever the quadrants are, it's always used, we draw a triangle using an acute angle. So that is another observation. That is over here, irrespective of quadrants, triangle is drawn with an acute angle because the decision maker is the basic angle. All good. So now coming back to this. So cosine of theta is 2 over root 7. So therefore, this is theta, this is 90, this is 2, this is root 7. This is the opposite. Let's work it out. Root 7 whole square, that is opposite square, plus 2 square. This is 7 opposite square. This is 4 opposite square is 3 opposite is root 3. So opposite is root 3. All good. This is by calculation. We are in the fourth quadrant. We know that in the fourth quadrant, cosine is positive. Only cosine is positive. So now if I write, and this question has to change, of course, this will become sine theta. So sine theta is opposite, which is root 3 over root 7, which can also be written as 3 over 7 square root. And what else? Let me just push this thing to the side. Okay, let me write tangent. Tangent of theta, that is opposite over adjacent. Since only cosine is positive, therefore sine is negative, sine is negative, tangent is also negative. All got all clear? It's so simple, provided you want to keep it simple. Worked example 5. So now this is worked example 5. Sine theta is 3 over 5. Let me write symbolically. This is, let's say, 1 over k. So let me write this thing as 1. Let me write this thing as k. This is acute. First quadrant. Only sine is positive. Only sine is positive. So now this is 1 over k. That means this is 1, this is 90, this is theta, this is k. Therefore, this is k square minus 1 square root using Pythagoras theorem. Got the idea? That is the base. So now we are interested in cosine theta. Cosine theta is 1 over k square minus 1 square root. Tangent theta is 1 over, I think I've written that for cosine. So let me just write this thing properly. For tangent, that is 1 over k square minus 1 square root. Cosine is k square minus 1 square root divided by k. Since only sine is positive, therefore cosine is negative, therefore tangent is negative. So it's just symbolically that we have used this. Nothing special. It's again an application of Pythagoras theorem. Now let me add some more spice to it. Let me go to the very top first. Now over here, let me write third part. Part C. Cosine of 180 minus theta. Or part D. Tangent of 90 minus theta. So now we have to apply this rule. That is cosine of 180 minus theta is negative cosine theta. That is negative. What is cosine theta? Cosine theta is over here. That is 4/5. Tangent of 90 minus theta, that is 1 over tangent of theta. That is tangent of theta. 1 divided by 3/4. That comes out to be 4/3. So something like this can be used. No big deal. Very simple. Over here, there's no space. So let me go over here. So this is part A, this is part B. Let me write part C. That is sine of 90 minus theta. Or for that matter, part D, tangent of 180 minus theta. So sine of 90 minus theta, what is the rule? First write that. That is cos theta. There is cos theta, which is minus 4/5. Tangent of 180 minus theta is negative tan theta. That is negative. What is tan theta? That is 3/4. So therefore, this is 3/4, and then you can write the answer. So now we have done a lot over here. What we have done so far, let me recap it for you. So this was lecture number 1 of trigonometry. We talked about exact trig ratios of 30, 60, 45. We talked about complementary angles, their rule. We talked about supplementary angle, their rules. We talked about what is the basic angle. We talked about quadrants. We talked about the relatives 30, 150, 210, 330. These are the relatives of 30. We talked about relatives of 60, 60, 120, 240, and 300. We talked about the relatives of 45-degree angle, that is 45, 135, 215, 225, and 315. 225 and 315. We talked about exam type questions. They are based on the decision maker, that is the basic angle. They are based upon triangles, right angle, that is, and they are based upon the concept of quadrants. And that is what we have done so far. So stay tuned for more content on Mathematics with Shahab Yaqub.